Alright, so we're going to move on to practice 2 TIPERS. Now, to remind you on what TIPERS are, these are problems that are usually less math-based but a lot more thinking. So instead of using all those equations and plugging in variables, maybe we'll look at the equations, but we shouldn't really be solving anything too in depth. So this first page, I want y'all to do it on your own and then see what I do. These TIPERS problems, if I just tell you all the answers, they really don't work out. You have to try them on your own. They want you ranking the amount of time it takes, like rank them. Whoever takes the longest is on the left side. Whoever takes the least amount of time in the air is on the right side. Rank them greater than, equal to, less than, and then do the same thing but horizontal distance. So pause the video and then we'll reconvene. So hopefully y'all pause the video, and what I will say about this is that as far as time in the air goes, our acceleration, the only acceleration in projectile motion, is in the y direction. Negative 9.81 meters per second squared. So horizontally should not affect the time in the air. The only way horizontally could affect time in the air is if you hit like a wall or something's in your way, and that stops projectile motion. That is not what's happening here. It looks like these spheres will be able to just hit away in general. So whatever works against my acceleration is the only thing that can affect my sphere. So all of them have the same AY, and the way they're coming off the tables, all their V0 Ys are the same. They're all 0 meters per second. Notice they're all leaving horizontally. If you remember, whenever anything leaves horizontally, it means V0 Y is 0. Very important thing to note. So the only thing that can affect it is height. And look at that. There's only 2 heights. There's either 1 height or 2 height. Also, just so we note, mass will not matter for projectile motion. I can write out all the equations again, but none of our equations include mass. If you don't believe me, I would say find 2 objects that are same shape, but one is clearly heavier. Try to drop them. They'll hit the ground at the same time. So let's rank these. So we have anything with 2 height is greater. So D is equal to F is equal to G is equal to I. These are greater than A is equal to B is equal to C is equal to E is equal to H. So that one is pretty straightforward, I think. What's maybe not as straightforward is this horizontal distance. Now, let's find an equation that even uses horizontal distance. So I have delta x, that sounds like horizontal distance, is equal to V0 x times t. Alright, V0 x, that looks like it's going to be whatever the v's are. And remember, there's no acceleration, so if it starts at v, it stays at v the whole time. Starts at v over 2, it's always 1/2 v the whole time. So V0 x I can get pretty quickly. Time is a little different. Time is based off the height of the object, right? We just did a whole thing about who's going to be in the air for longer. So I know all the 2 heights are going to be equal and all these heights are equal. So let's just start solving some. So I think the easiest one is to see the one that goes the furthest and the one that goes the least. This object has the greatest height, the greatest velocity. It's going to go the furthest, so G. And remember, does not matter about the mass. The last one, the one that's going to go the least is E, because it doesn't even have any forward velocity. It's just being dropped, essentially. Alright, now we need to fill in here. So we're looking for objects that have at least double. So, of one thing, but not double the other. You have D, F, and H. So I'm looking at this, and D and F, they're going to be equal to each other, but they have 1 velocity versus 2 height, while H has 2 velocities versus 1 height. Now, if you double the height and you double the time, they would all be equal. Without getting too far into it, I'll show you what happens when you actually double height. So for example, I'm going to use 5 as my height here and show you what happens to my time. So, and we'll say you're dropping something negative. When you solve this out, t will equal 1 second. Well, what if I double my height here? if you work all this out, t is equal to square root 2, which is equal to 1.414 seconds. So you do not, when you double the height, you do not double the time. And because of that, basically velocity is more important. What I'll say is just, I'm not going to get that specific on the test, but it's something important to note. Alright, so using that logic, if there's ever a tie between like different h's and v's, when you're like multiplying the constant in front of them, velocity is more important. So I'm left with A, C, H. B is the slowest one of those, if you notice. So B is the slowest one. So we have A, C, and H. So just with or sorry, not H, A, C, and I. So I is double the height but half the velocity. Now, according to this, because they prioritize height, which doesn't actually double the time, it only increases it by a factor of square root 2, I is less than A is equal to C. And this is my order. A little bit more confusing. Hopefully y'all can read that. But yeah, we're doing decent on time. I'm going to let y'all, now that you've done this first page, I want y'all to do the rest of this and see if you can get the right answers. I'm just going to go by pretty quickly and answer them. So hopefully you pause the video. Alright, so now we're looking at horizontal distance. Alright, horizontal distance is, we just did a problem on this, delta x is equal to v naught x times t. Now, when you're doing these problems, you have to see, alright, v naught x, 20, 20, 20, 20. It's going to be 20 the whole time, so these are all the same for all the objects. So this will not factor into delta x. The only thing that will factor is time. Now, basically, if we can rank all the v naught y's, then that's going to tell us who's in the air longest. And I can tell by the height, the angle here, that this one's going to be the air, like this is going to have the greatest v naught y. If you do 40 times sine of 60, you'll get a value for your v naught y, and you can do that for all of these guys. So you do like 28.3 sine of 45. Actually, no, this one's 20, and I know this one's sine of 30. It's going to be half of 23.1. It's probably like 11.5 or something like that. So 11.5, 20. I think this one's like 28.3. So anyways, and this one's also 20 because it's the same angle. The mass of the cannonball does not matter. Remember, mass does not matter. If you know it's going that velocity, it's just going to end up traveling the same way. There's no air resistance, so it's D, B is equal to C, and then A. And the reason is basically it's the order of the v naught y's, because those indicate which will have a longer time in the air. Alright, we have a student. They say the faster you go, the less time it takes to get there. The truck in case A will be in the air longer. And what I'll say is that, so their height A is equal to height B, and v naught ya is equal to v naught yb. They're both 0 meters per second. So they will be in the air same amount of time. And that's pretty much it. It's just the only thing that would change is that B is going to go further because it has a more velocity, but that doesn't mean it's in the air longer. Alright, this problem. Rank the time the cannonballs are in the air. So remember, we kind of worked out what time could be. So if we think about delta y is equal to 1/2 gt squared plus v naught yt, what you'll notice is that, or let me back up actually. So anything that goes against a of y, the g, the negative 9.81, is what we're looking for. And you can see here that there's two things that seem like they matter for v naught y. It's g, it's delta y, and it's v naught y. So if any of these factors change, that's what it is. Now I know these cannonballs are probably released at different heights of the cannon. Let's just assume they're at different height, or they're at the same height. So I'm gonna say this is the same. Our v naught y's, well, if I look at it, they all look the same as well. So I'm gonna assume that they're all going to be in the air for the same amount of time. Now, if you're going to say like maybe this height is different, I mean, I'd understand that. You could say that, and that means the angle of the cannon is basically what's going to determine it. I'm going to assume that that is not the case, though, so I'm going to say all the same. They're all the same height, so. All right, this one. All right. I'm just going to say same as last time. The time in the air for A will be equal to the time in the air as B. It's the same thing as last time. I think this time this guy would be traveling at 2V. This one's at V. Yeah, so essentially they flip places, but just because you're going faster horizontally does not mean you're in the air longer. It just means you go further. All right, thanks, guys. We're going to move on to some more practice problems in the next page.